Good day, everyone. My name is Naguio, member 3, and we are now to perform functions of Python along with the member 2, and then the first member will do the problem 1.
So good day, I am the member one will be performing the problem one. So first, let me share my screen. So this function referred to as the encryption function and is designed to encode a given text by shifting each letter a certain number of positions in the alphabet text. So we encrypt text shift in text. So the text parameter represents the original message to be encrypted, while the shift indicates the number of possessions to shift each letter. So it processes each character in the text sequentially. So if the character is a letter, it computes the new character by adding the shift value to the ASCII value of the character. So for lowercase, um, we have here the then another 6. So subtracts the ASCII value of A from the characters ASCII value as the shift value and then applies modulo 26 which is indicated here. So to wrap around the alphabet before adding the ASCII value of A. Similarly, for uppercase letters, it performs the same operation but with A, capital A instead of small letter a. So non-alphabetic characters are included in the encrypted text without alteration. Ultimately, the function returns the encrypted text. So now let's proceed to the decrypt. The decrypt function reverses the encryption process to decrypt a given text. So here is the function. Text sheet. So it takes as input the encrypted message and the original shift amount used for encryption. By invoking the encrypt function with the negative of the original shift amount, it shifts the letters back by the same number of places. So effectively reversing the encryption and returning the decrypted text. So the next one from the list is wall of the class with one string so for instance, when the encrypt function is invoked, it receives a plain text and a shift of value of 1, which is indicated here. So this shift operation moves each letter in the plain text by one position in the alphabet. Similarly, the decrypt function is utilized when the encrypted text and the identical shift value. So this action reverses the encryption process by shifting each letter in the encrypted text back by one position, ultimately revealing the original plain text. So let me continue my code. So this was the final code. So let me run it. So as you can see, the result is here encrypted text and the decrypted text. So this piece of code illustrates and fundamental encryption and decryption technique using the Caesar cipher. So it serves as a straightforward yet efficient method to grasp the fundamentals of encryption and its application and maintaining message confidentiality. So that will be the problem one. Um, so the problem two will be performed by Miss Rosalie.
Excuse me, number one.
Yes.
I have a question. Can you explain the concept? some paper and how the functions work.
Thank you for that question. As I answered, scissor zipper is one of the earliest known and simplest zippers. So used for encryption and decryption. So in this zipper, each letter in the plain text is shifted to a certain number of places down or up the alphabet. So, for example, the for example, la, the yung pinreform ko kanina with a shift of 1, then the capital letter A would be replaced by D, and then D would become C, and so on and so forth. So that would be my answer.
Okay, thank you.
Good day, and I am Rosalie Paculanan, who performed the Fraudin tour. And now, let's share my screen. And add new tab and search Jupiter. And now I will discuss and perform the problem 2. The problem 2 is about calculating a final grade for a student based on the three components, which is attendance, quizzes, and task performance. Each of these components has a specific weight in the final grade calculation. And let's start to put. First, div, space, and compute, underscore, final grade, underscore, and the grade, and close parenthesis and open parenthesis, and add attendance, quizzes, and the last one is the task performance, underscore and performance, and add semicolon. Enter, and if final underscore grade. equals 75. And enter remark equals pass. Space and just add else. Remarks equals fill. And add print open parenthesis and close parenthesis. Final grade, add colon, and just add curly bracket. Final grade, add colon, and also this one. That's 2F and minus, add another curly brackets and add remark. Space and just type the return final grade and this is the first part. Each part has a weight being percent. It worth 20% of the grade. Doing well on quizzes is worth of 50% and doing well on the task is worth of 30%. The function adds up of the parts. It's multiplied by the weight to get the final grade. If the final grade is 75 or more, the student passes. If it is less, they fail. The function lets you see the final grade and whether the student passed or failed. So let's say a student has a attendance score of 85, a quiz score of 90, and the task performance score of 80. And let's add example usage. Just enter and type the example usage. And add attendance is 85 and the last and the second is quizzes, which is 90. And the last one is the task performance. Iterate some and compute the final compute underscore final grade and add open and close parentheses and add attendance, quizzes, and the last one is the task performance. So these all my goods. So since this is my final code, this I will run this. So this is the final grade, which is the 86. So pass the compute the final grade function, which is a simple way to figure out if a student passed or failed based on the how often they were present, how well they did on quizzes, and they will did on tasks. It a practical tool for understanding student overall performance. So that's all.
Excuse me, number two, I have a question for you. My question is, why it is possible to calculate values using Python code?
Um, it is possible to calculate values using Python code because Python is, like many other programming language, allows you to perform calculations because it's designed to execute instructions, including mathematical operations. Because of syntax of mathematical operations, data types, built-in and math functions, libraries, and package. Expensive, and the last one is fixability. Overall, the Python design and features make it well suited for performing calculation and numerical analysis, whether for simple arithmetic or advanced mathematical modeling. That's all.
Thank you for your great answer. And that will be our performance in TP4 in Python functions. Thank you, everyone. God bless.
Thank you, bye.